this is Mrs. Brown, and today we're looking at solving quadratics using the quadratic formula. Okay, this is actually the fifth method that we've looked at in solving quadratics. And the nice part, this one always works no matter what. So sometimes like factoring and stuff doesn't work so well, so this is a good one. All right, so solutions to ax squared plus bx plus c equals 0. This is the standard form. So when we have it in standard form and a is not equal to 0, we can use the quadratic formula. And the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. Okay, and basically these are your steps. You're going to rewrite the equation in standard form if it isn't already in standard form. So it has to be like this. So if I have something like equals 10, I have to solve it so that I have it equaling to 0. And I want to set it up in this format with being in standard form with the square first, and then the middle term with the x, and then the constant. Okay. Then you're going to identify what a, b, and c are, substitute them into the quadratic formula, and solve it. So let's look at some examples. Remember, you can pause the video and write down the steps if you need to. Okay. All right. So if I take a look at this first quadratic equation, it's already in standard form. I already have it equaling to 0. I have my square, my not square, and my constant. Okay. So the first thing I want to do is identify a, b, and c. Remember, when there is not a number that's listed, that's 1. So a is 1, b minus 10, so negative 10, and c is going to be 16. Okay. Then I want to write out my formula. And actually, here's the thing. If you write out the formula for each problem before you substitute it in, you're less likely to make mistakes when you're substituting stuff in, and you're going to memorize the formula. It's actually, I had it memorized when I started teaching algebra from when I took algebra, just because I wrote out the formula so many times. So negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. And now I know my numbers, so I'm going to substitute those in. You really want to be careful when you're substituting a negative number in because it's really easy to mess up. It's negative whatever b is. So in other words, we're saying the opposite of b. So minus minus becomes a plus. So this is actually going to be a positive 10 once we simplify it. This is one of the most common mistakes that happen when people are using the quadratic formula. This is the opposite of what b is. If b is negative 10, this is going to turn into positive 10. Plus or minus the square root. Okay. Substituting, again, a negative number into parentheses. So it's negative 10 times negative 10, not 10 squared made negative. So make sure that you are getting that correct. A is 1, C is 16. I kind of have to extend that. Divided by 2 times 1. Okay, now I'm going to start simplifying, and I'm going to do it in a couple of steps so you guys can kind of see what's going on as I'm doing it. Okay, so minus negative 10. So the opposite of negative 10 is just 10. Okay. Plus or minus the square root. Okay, that's going to be 100. Minus, and 4 times 1 is 4, times 16 is 64. Divided by 2. So that's going to be 10 plus or minus the square root of 36 divided by 2. Notice I'm not dividing by 2 yet, okay, because this is an addition or subtraction, so I'm going to have to divide both things, or I'm going to have to add first. Okay, so I want to make sure that I do that, and you can't divide it because this is outside of the radical, so we have to take the square root first. All right, so the square root of 36 is 6, so 10 plus or minus the square root of 6. The reason we're using plus or minus is because, again, negative 6 times negative 6 is 36, or 6 times 6 is 36. So there's 2 possible solutions. So remember, that's where we're going to break this up. We're going to look at both scenarios. So 10 minus 6, and if it's 10 plus 6 divided by 2. Well, 10 minus 6 is 4, divided by 2 is 2. And 10 plus 6 is 16, divided by 2 is 8. So the solutions to this, where it would hit the x-axis, are going to be 2 and 8. Okay, let's take a look at another example. All right, So on this one, the first thing I notice, it's not in standard form. It's not equal to 0. I have to move my negative 11x by adding 11x to both sides. So I should have 4x squared plus 11x plus 6 equals 0. I then identify A is 4, B is 11, C is 6. I'm going to use my quadratic formula. So negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2 times a. Okay, now you take the time to substitute in. All of these numbers are positive this time, so there's not anything like tricky. So it's a matter of just kind of substituting it in and finding your solution. Okay. Whole thing divided by 2 times 4. Okay, so when I look at this, I start simplifying. Again, I'll do it in a couple of steps so you can kind of see what's going on. I do 11 squared is 121 minus, that 16 times 6 is 96. The whole thing divided by 8. Okay, when I subtract this, okay, that's going to turn into 25. So I get negative 11 plus or minus the square root of 25, the whole thing divided by 8. Okay, the square root of 25 is 5. And so what's happening is I'm getting negative 11 minus 5 divided by 8 and negative 11 plus 5 divided by 8. Again, the square root of 25 could be positive 5 or it could be negative 5 because both of them will work. This gives me negative 16 divided by 8, which is negative 2. This is going to give me negative 6 divided by 8, which simplifies to negative 3/4, and I would just leave it as a fraction. Okay, so my two roots are negative 2 and negative 3/4. If I were to convert that to a decimal, it would be negative 0.75. And if my directions told me to round, I'd probably put negative 0.8, but as I said, fraction's good for me. All right, so once again, as I'm looking at this problem, it is not in standard form. I have a minus 3 instead of equal 0, so the first thing I'm going to do is add 3 to both sides. Okay, again, writing out your formula, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Okay, again, writing it out each time means you're less likely to make a mistake when you're substituting, and you're memorizing it. Makes it easy. It's a really quick way. You take like 2 seconds and you're studying, and every time you do that, you're studying, and over time, you're just going to remember it without any effort. And it just really helps to do that whenever you're dealing with any formulas. That's a good way to memorize it, whether it's science or math. All right. I didn't identify A is 1 because that's the coefficient of 1. B is negative 7 because that's minus 7. And C is going to be 3. All right. So once again, B is negative. So this is the opposite of B. So the opposite of negative 7 is 7. So that's going to come out positive. Substituting it into parentheses when you have a negative number is going to prevent you from making simple mistakes. It's a really good strategy to help yourself not make little mistakes. 4 times 1 times 3 divided by 2 times 1. All right, so starting to simplify, the opposite of negative 7 is 7 plus or minus the square root. Negative 7 squared is 49 minus 12. The whole thing divided by 2. So this is going to be x equals 7 plus or minus the square root of 37 divided by 2. Now, this is not a perfect square. You're going to get a decimal. And in fact, it comes out to like 6.08. We can just round that to the tenths place is what your textbook is asking you to do the final answer anyway. So I'm just going to use 6.1. So this means that I have 7 minus 6.1 divided by 2 and 7 plus 6.1 divided by 2. Those are my two possibilities. I get 0.9 divided by 2 and 13.1 divided by 2. So this is going to be 0.45 and 6.55. Which if you're going to the hundredths place is perfectly fine to have that. But if you're being asked around to the tens place, that means 5 tells you to go 1 up. And so I would put the answers of 0.5 and 6.6. Okay. So again, even if it doesn't come out even, you're going to be doing a little bit of an estimate. Rounding to the tenths place is the directions from the textbook, but sometimes you may have directions like round to the nearest hundredths place. So just pay attention and read directions. That's always important. All right, one more example, and then we'll move on to something else. This is already in standard form. So I'm identifying A is going to be 1, B is -5, and C is 13. So when I take my formula, negative b plus or minus the square root of b squared minus 4 times ac, the whole thing divided by 2a. Again, writing out my formula is helping me study. Okay. So negative, it's a negative number substituted in parentheses, the opposite of -5. So that's going to turn into a positive. Okay. And the whole thing divided by 2 times 1. So I end up with 5 plus or minus the square root of 25 minus 52 divided by 2. Now, right now, I have a problem. And that problem is when I subtract this, it's going to come out to -27. Well, that means there are no real solutions. You can't take the square root of a negative number. It's not a real solution. There's imaginary numbers, but that's a whole other lesson. So there's no solution. So the answer to this is there's no solution, and it's because this number underneath the radical sign came out negative. And actually, this part right here under the radical sign, we call the discriminant. And if you look at the discriminant, whether it's positive or negative or 0, that actually tells you how many solutions there are. And so that's what the last part of what we're going to talk about today. So the expression under the radical sign is called the discriminant. So you have b squared minus 4ac. And here's the thing. If the discriminant is negative, like we just saw, there's no solution. What that means is it's not going to intersect the x-axis. So it's going to be above, the vertex is above and it's pointing up, or the vertex is below the x-axis and it's opening down. This is not going to intersect, so there's no solution. Okay? And here's an example. It's the problem that we just did. The discriminant comes out to -27, so therefore there's no solution. Okay? If the discriminant is 0, there is exactly one solution. What that means is the vertex is actually on the x-axis. So it only intersects the x-axis once, which means that it is one solution. So here's an example. It's a perfect square. When you look at this, you end up substituting in for the discriminant. You end up with 36 minus 36, which is 0. That tells you that there's only one solution. Okay. The final case is positive. If your discriminant comes out positive, which most of the examples we did were, that means there's two solutions. It intersects the x-axis in two places. And so if we take a look at this example, and we didn't actually do one like this, notice that C is negative. So what's going to happen is you end up with -4 times 1 times -20. That turns into +80. So make sure that you're watching that because, again, that's a common place where people make mistakes. C is negative. So when you're multiplying this all out, this becomes positive because it's like -4 times +20. So it's going to become a plus. And so 1 plus 80 is 81. And so therefore it is positive. And you have two solutions. Okay. So let's recap. You've got 5 different methods for solving quadratic equations. We can use factoring, graphing, using square roots, completing the square, or quadratic formula. Most of the time, you're probably using one of the ones in purple. Okay. Completing the square, if you're comfortable with that method, use that method. That'll actually come in handy later in math. Graphing is probably not everybody's first choice. However, if you just need an estimate, it's not bad. And if you have access to something like a graphing calculator or using something like GeoGebra, that's totally fine to use graphing to solve it, especially if you don't need an exact answer. Factoring, you want to use it when it's easy to find. So when you're looking at that and you're like, ooh, that's easily factorable, that would be a good time to use factoring because it's going to be faster than something like the quadratic formula. But if it's something that's really hard to factor, or some things are really just basically you can't factor successfully, then you definitely want to use one of the other methods. Okay. You can use square roots if you can get it in this form where it's just x squared equals n. So that means there's no like 2x term, there's no b term in it, and then that would be an appropriate way to do that. And again, way faster than the quadratic formula if this works. So it's good to have the different methods because some things are going to be easier than others depending on the situation. Completing the square, you can really use for any of them. Remember, a has to be 1, so if it's already like x squared plus, 5x plus 7, it's pretty easy just to use completing the square. And then finally, the quadratic formula, which we talked about today, is good for any of them. So it does take a little bit longer to fill out all the formula and all that kind of stuff, but it works, okay? I hope this helps and have a fabulous day.